All right, multiplying polynomials lesson 3. So multiplying integers is similar to finding the area of a rectangle. In the past units, we've done area is equal to length times the width. We've also done area is equal to the side squared if we're doing, 1 square. Well, for any rectangle, the area is length times width. We can use algebra tiles and the area of a rectangle to help us understand the multiplication of integers. So when you multiply a positive by a positive, the product is positive. So positive multiplied by a positive, we still end up positive. If a positive is multiplied by a negative, the result is negative. And also a negative multiplied by a negative, the result is positive. So here's one example. We've got 2 multiplied by 6, and the answer is clearly 12. Well, we can show that with algebra tiles. If you recall, each one of these little tiles is positive 1. So positive 1, positive 1, positive 1, positive 1, etc. And these are also positive 1s. Well, positive 1 multiplied by positive 1 is going to give us positive 1. And we can draw that in the space here. And we follow that same argument that positive 1 multiplied by positive 1 is the same for each one of these boxes. And after we fill all this out, these are supposed to be little squares, by the way, we can see that there are 12 of them, just like when we were multiplying integers. Let's do this one. 4 multiplied by negative 5 is going to give us negative 20. Well, looking in this array here of tiles, we're going to multiply these two. So this one and this one. So positive 1 multiplied by a negative 1 is going to give us a negative 1. And then we can just go through, oops, didn't want to erase that one, and do the same thing for the other ones. If we're multiplying this one and this one, we're also going to get a negative 1. And in fact, the whole array is going to be a whole bunch of negative 1s. And there's going to be negative 20, or there's going to be 20 of them. So our result is negative 20. Okay. So what we're doing here is we're multiplying this top row of things by the row on the left. And the resulting goes in the middle. One more example. Negative 4 multiplied by negative 3, that gives us positive 12. And this one you can kind of hopefully visualize here. So we're going to do negative 1 multiplied by negative 1 gives us positive 1. Okay? And then we've got negative 1 multiplied by that same negative 1 on the left is going to give us positive 1 again. And then we've got this negative 1 multiplied by that negative 1 gives us another negative 1. And we start the process over, except with the second one in the column. So that's also a negative 1. Or sorry, it becomes positive 1.
Julie Jensen, please come to the office.
Also a positive 1.
Jensen.
And these two also make a positive 1. And it follows that the rest of them follow the same pattern. Positive 1, positive 1, positive 1, positive 1, positive 1, and positive 1. So when we were just using integers, negative 4 multiplied by negative 3 gave us positive 12. And when we're using the algebra tiles, we get the same result. Algebra tiles can also help you understand the multiplication of polynomials. That is, multiplying polynomials is also similar to finding the area of a rectangle. So let's show this. So we've got 2x, that's represented by 2 vertical rectangles. And we've also got x plus 3, which is represented by 1 rectangle and 3 ones. So let's use the same method here. We're going to multiply the first thing by the first thing. And you use the same length and width. So this is this long, sorry, this wide, and it's this high. So we end up with a positive x squared. X multiplied by x is a positive x squared. And you can also think about that in terms of our powers. X with an exponent of 1 multiplied by x with an exponent of 1 gives us x squared. Okay? So let's just, this is a positive x squared there. And we get the same thing directly below it. We get this positive x squared. Okay? Well, let's work through the rest of this here. 1 multiplied by x is going to give us just an x, and it's positive. Same thing here, positive x, and positive x, positive x, positive x, and positive x. So what do we have here? Well, we've got 2x squared and we've got positive 6x. The resulting stuff in the middle we write algebraically. Let's try another one here. Negative x multiplied by 3x, so we have this width and this length, and then we have to think this is a negative and this is a positive up here, so it's going to remain negative. And the same thing follows here, and the same thing follows here. On these ones, however, it's going to be a negative multiplied by a negative, so we get a positive. So what do we have? We've got negative 3x squared and positive 2x. Perfect. Okay, here we're multiplying 5 by negative 3x plus 2, and that's represented by the vertical column and the horizontal columns. Okay? So let's go through this. We've got negative x, negative x, negative x, negative x, and negative x. We got a whole bunch of these, actually. Okay, and then we've got a whole bunch of positive ones. Get a thicker pen here. There we go. That'll go a little quicker. Awesome. So what do we have in the middle here? Well, if we count them up, we've got how many negative x's? And hopefully see that there is 15 of them, so negative 15x. And then how many ones do we have? And we've got 2, 4, 6, 8, 10. So positive 10. All right, the last one. We've got a negative multiplied by a negative, so everything inside is going to be positive. So we've got positive x squared, positive x squared, positive x squared, and so on and so forth. Okay, and then we get our positive x's here. Okay, and let's write down what we've drawn. Not the stuff that was there before, but the new stuff that we've drawn. So we've got positive 8x, so 8x squared, and we've got 12x's, so 8x squared plus 12x. So the rule is the monomial is multiplied with each term of the polynomial within the brackets. this is called the distributive property. Okay. What this means is you are going to multiply the negative 4x by the first thing. So negative 4 and negative 2 make positive 8. That's where this positive 8 comes from. And then x multiplied by x gives us x squared, and that's where the x squared comes from. And then you're also going to do the same thing. Negative 4 multiplied by negative 3 gives us positive 12, and then we also have an x. So, to clarify, let's do another color here. Multiply the coefficients and multiply variables using exponent laws. So instead of drawing out the whole thing, let's do it algebraically. Okay, so we're going to multiply the coefficients and we're going to multiply the exponents. So what we're actually doing here is multiplying the coefficients and multiplying the exponents. So 2 multiplied by 3 is 6, and x multiplied by x gives us x squared. Okay. Here, this means we're going to multiply the coefficients, so negative 1 multiplied by 5, and we've got x multiplied by x. So we end up with negative 5x squared. Okay, another one here, negative 4x multiplied by negative 3x. So you multiply the coefficients, so negative 4 multiplied by negative 3, and x multiplied by x gives us 12x squared. What happens if we have 3 terms? Do the same thing. So 3 multiplied by 2x squared gives us 6x squared. 3 multiplied by negative 6 is negative 18x. And 3 multiplied by 4 gives us positive 12. Negative 2x multiplied by negative 4x squared. So you multiply the two coefficients, so negative 2 multiplied by negative 4, and you multiply the exponents, so x multiplied by x squared. So 2 multiplied by negative 4 gives us 8x squared, or 8x cubed, okay, because you're adding those exponents there. Negative 2x multiplied by positive 3x gives us negative 6x squared, and negative 2 multiplied by negative 6 gives us positive 12x. Okay, when you run into fractions, you are still multiplying the coefficients. So 2/3 multiplied by 9 over 1 gives us 18 over 3, which simplifies to 6. So I get 6, and then the x and the x squared multiply to give me x cubed. Okay, 2/3 multiplied by 15. That's what we're doing here. So multiplied by 15 over 1 is 30 over 3, which simplifies to 10. So this becomes plus 10. And then the x and the x multiply to give me x squared. And lastly, 2/3 multiplied by 6 is 12 over 3, which reduces to 4. So then I get minus 4x. Well, we have two sets here, same process. 3 multiplied by 4 is 12. 3 multiplied by negative 3x squared, well, 3 times 3 is 9, and 3 times negative 3 is negative 9x squared, plus 2x and 6x squared. We're not quite done because you can actually collect like terms, the stuff that we were doing yesterday. So negative 9 and positive 6x squared simplified in negative 3x squared, and the 12 and the positive 2x, or sorry, there's nothing else to combine with those things, so those just stay as they are. Three terms, so 2 multiplied by negative 7 is negative 14x squared. 2 multiplied by negative 4 is negative 8x. 2 multiplied by negative 2 is negative 4. Negative 4x, remember we keep the negatives, multiplied by 5 is negative 20x. And negative 4x multiplied by negative 3 is positive 12x squared. So let's see if we can combine any stuff. Well, we've got 14x squared and 12x squared. That's going to simplify to negative 2x squared. Then we've got negative 8x and negative 20x gives me negative 28x. And lastly, negative 4 has nothing else to combine with. So we're just going to tack it on the end there. Another example here. Is there a coefficient out front here? And the answer is no. There's nothing to distribute. So if there's nothing to distribute, you can simply drop the brackets. So I'm going to rewrite the same stuff just down below. However, the second part here, there is a negative 3x to distribute. So negative 3x multiplied by x squared is negative 3x cubed. Negative 3 multiplied by negative 2x is positive 6x squared. And negative 3 multiplied by 4 is negative 12x. And let's look for stuff that we can combine. So negative 4x squared and positive 6x squared. That's going to give me negative, we should start with the negative 3x cubed. Let's start with that. So negative 3x cubed. Then let's do our negative 4x squared and positive 6x squared, which is going to give me 2x squared. And then we've got the 3x and the negative 12x, which will simplify to negative 9x. And lastly, we've got negative 6, which has nothing else to combine with it. So let's just leave that on the end. Determine the area of the rectangle below. Well, area is the length multiplied by width. And if this is the length and this is the width, the area is 5x squared multiplied by 3x squared plus 2x. Now let's use the distributive property. 5x squared multiplied by 3x squared is going to be 15x with an exponent of 4. And then 5x squared multiplied by positive 2x is going to give me positive 10x cubed. So the area is 15x exponent 4 plus 10x cubed. All right, a piece of paper has margins that are 2 inches on the sides and 3 inches at the top and bottom. The height to width ratio of the usable part of paper is 3 to 2 as shown in the diagram. Write a polynomial expression that represents the perimeter of the paper, including the margins. So we have to figure out something here. The perimeter is the sum of all sides, so that there's 2 lengths plus 2 widths. We need to figure out the lengths and widths. So the margins are 3. So if this is 3 inches here, this is also 3 here. And if that part there is 3x, the entire part here is going to be 3x plus 6. The 3x here, and the 3, and the 3. And following the same sort of thinking, this part here is 2x, and the margins are 2 inches. So the width is going to be 2x plus 4. Okie dokie. So we've got the length, we've got the width. So length is equal to 3x plus 6, and the width is equal to 2x plus 4. So if the perimeter is 2 multiplied by the length, we're going to go 2 multiplied by 3x plus 6, and we're going to add that to 2 multiplied by 2x plus 4. And if we expand, we get 6x plus 12 added to 4x plus 8. And if you collect like terms, you end up with 10x plus 20. is the perimeter. So, therefore, the perimeter of the paper is 10x plus 20.